Hello, sorry I can't be with you today. I'm currently at home self-isolating while we wait for some COVID tests. So you will obviously have a cover teacher, and I have prepared this video for you. So you should be on to lesson B4.3, I believe we're on, which is all about helping the heart. So we're going to have a look at what the heart does, potentially some issues in it as well, and how we can overcome those. So you might want to follow along in your booklets as well. It's from page 21 onwards. Hopefully you've done the do now task as well. So we've got here a diagram, very badly drawn, of the heart. I'm just going to quickly go over what is going on in it as well. We start up here. We've got this blood vessel going in. Blood is going into the heart, and through this blood vessel, it is the vena cava. And this is where blood goes into the heart. It goes into the heart, into this first bit, into the right atrium. I'm not going to write it all out, but we've got RA there. Goes into the right atrium. The right atrium then contracts and pushes blood through some valves on the right hand side, so they are tricuspid valves. Got that R in it from the right hand side, into the right ventricle. We've gone from the right atrium and into the right ventricle. The heart then contracts again and forces the blood to go out through this blood vessel here. We can go two ways out of here. This is going away from the heart, so it is an artery, a specific kind of artery. It is the pulmonary artery. It's going to the lungs. So we've got the pulmonary artery. That's going to the lungs. Now you'll notice I'm doing this in blue pen at the moment. This is because the blood at this point has no oxygen in it. It's how we represent blood that has no oxygen in it. Obviously in real life it is still red, but when we're drawing it we represent it as blue, so we know that it is deoxygenated. So the blood goes to the lungs. At the lungs it gets oxygen, it gets rid of that carbon dioxide, it diffuses from the blood out into the lungs, and oxygen diffuses from the lungs into the blood where it attaches to the hemoglobin of those red blood cells and comes back to the heart. We come back to the heart, let's just draw our parts there, via our pulmonary veins. So pulmonary again linking to the lungs, and veins because we're going back from the heart or back to the heart. And it's now oxygenated. The blood comes in and goes into the left atrium. Now in the left atrium, remember these sides are swapped round for as we look at them, but they're what are on our own hearts. The heart will contract again, top part, and it forces the blood down and into the left ventricle. The left ventricle contracts again, and we force the blood up through this blood vessel here, this large main blood vessel. It's going away from the heart. It is called our aorta. It's carrying oxygenated blood away from the heart. Now, there's a few valves that I've forgotten to add on. I'll add on now. We've got one on here on the pulmonary artery and one on here on the aorta. And these are to stop blood going back the wrong way. We've got our tricuspid valve here. We've got our mitral valve on this side. And we've got these two ones here, which are called our semilunar valves. So semi, just like in a semicircle, is half. Lunar means the moon, so it looks like half of the moon. It looks like half the moon. So it's just half a circle we can think of are these valves here. Now this is how blood flows around the heart. Should all work perfectly normally. Now there are a few issues that we can get. We can have what is called leaky valves. Get a new bit of paper for this bit. So we can have leaky valves. Now leaky valves, we've got our valves on these parts here. 1, 2, 3, 4 valves between the atrium and the ventricles, and then at the pulmonary artery and the aorta. If these valves are leaky, so if they don't properly close, it can allow blood to go the wrong way. So as blood goes from the right atrium into the right ventricle, it then needs to go out through the pulmonary artery. It does that by the ventricles contracting and forcing blood out this way. If this valve doesn't close properly, or it's a bit leaky, then actually blood can end up flowing back that way, which we don't want. We don't want blood to go the wrong way around the heart. The same on the left-hand side. We could get blood being forced back up that way and going the wrong way. It's going to struggle to go too much the wrong way because we've got blood at high pressure coming this way and stopping it, blood coming that way, stopping it. But it means that the heart's going to struggle to pump blood to the right direction, going into the arteries and going away from the heart. So we can have leaky valves, and we can get the backflow of blood. So if we were to have a look at a valve, cross section, this is where the blood is coming through. The valves should be completely closed and only allow blood to go through one way. When we have leaky valves, what we find is there is a gap in the middle, and this will allow blood to go back through the wrong way. So blood can come out and blood can go back that way as well, which we don't want. Now there are a few ways that we can fix this. So we can either give a transplant, and we can use human or animal tissue. We get the human ones from donations, so organ donations. Animal tissues we will take from animals. So we can use pigs and cows. They have valves that match as they are mammals as well. It all matches up. We can use their ones. Now, the great thing about using a transplant is that we don't need to take any medication or very little medication. So there's no medication. But they only last about 10 to 15 years. At which point we'll need to put some new valves in, so the person might need to have surgery several times. We can also get a mechanical valve. Now this is made of titanium usually, which is an expensive metal. Okay, we only need a very small part to go in the valves. It doesn't need replacing. So once you've got it, you can keep it in forever. So only need to have one surgery to put it in. However, you do have to take medication to stop the blood clotting. So daily medication to prevent clots. Now both of these have obviously their benefits. The benefits for the human or animal one, there's no medication needed. And for the mechanical valve, it doesn't need replacing. However, there are obviously downsides and disadvantages. So the human or animal one will only last 10 to 15 years. It will need replacing. So if someone who is in their 20s had a valve replacement, they're going to potentially need 5 or 6 major heart surgeries to replace it in their lifetime. Someone who's got a mechanical valve doesn't need it replacing, so much better for someone who is younger. However, they will need to take daily medication to prevent blood clots. If they got a blood clot, this could lead to a heart attack or a stroke. So the next part we're going to look at is pacemakers. Now, you may know someone yourself who's had a pacemaker fitted. It's generally older people, but it can be younger people as well. Now, our heart has a natural pacemaker, and that sits in the right atrium. And the natural pacemaker sends electrical signals throughout the heart and tells it to contract. So it makes it contract at the right speed and at the right rate. So normally, our hearts will beat at 70 beats per minute, give or take. Some people will be down at 60 beats per minute. Other people will be at about 100 beats per minute. When you do exercise, obviously this increases because you need to pump blood around your body faster. And when you are resting or asleep, it goes lower because you're not doing as much exercise. You don't need to get the blood going around as fast. But generally, it will sit in this range at about 70 beats per minute. And it will have a normal rhythm. You might have heard on TV or any medical dramas where they say, they're in sinus rhythm. Sinus rhythm is normal rhythm. Now, occasionally we can get something called arrhythmias. Now, like all things in science, when we put the letter A or an in front of something, it means not. So we've not got a normal rhythm. It's rhythmia, rhythm. So not a normal rhythm. And this is where the heart can be pumping or beating slightly wrong, so they had a sync, not going fast enough. Some people can't get their heart rate to increase when they do exercise. Some people, it stays constantly high. Other people will have a funny heartbeat, and they've normally got a problem with their natural pacemaker. So what we can do, we can insert a mechanical pacemaker. And this is a little box, often, that has wires connecting it to the heart. This will then tell the heart what to do. It's going to have a rhythm, so we will get a rhythm set in there, and it will beat regularly to make sure the heart is pumping at a good rate. Now, see, the problem with this is it's very hard to increase the heart rate. And it also needs to stay in. We need to change batteries regularly. And it's also very explosive. Now, you might be wondering why I'm telling you that it's very explosive. One of the things that has to be done in hospital when someone has died is that they have to have it confirmed that they had no pacemaker. The reason being, we are now cremating more and more people. So we are burning people when they've died to get their ashes. If we were to put a pacemaker into the furnace that they burn people in, it would explode and cause a lot of issues. So it has to be verified that someone who's died does not have a pacemaker, so they can be cremated. The last thing we're going to look at is heart failure. Now, this is where the heart has failed for a variety of reasons. Generally getting weaker if it's got too many leaky valves or too many issues on there. And it can be an issue. The heart needs to be replaced. We need to replace it. Now, up until recently, we had to wait until we could have a transplant, where you would take a heart from somebody else and insert it into the person that needs it. Now, obviously, to have a transplant, you need to have someone that has died and is on the organ donor list, so willing to give their heart or their organs after they've died, and the heart needs to be in good condition. That was quite hard to get, so we had a short supply of hearts or donor organs. It's not just limited to hearts. we are struggling with all donor organs. If you know anyone that needs an organ transplant, you often find they are on the waiting list for a very long time. A few years ago, we were able to invent mechanical hearts. Now, just like the normal heart, this is a pump. It will pump blood to the lungs and around the body. And we found by giving people these mechanical hearts, they didn't need to be on the transplant list, and it could improve their quality of life. Now, obviously, again, we still need to make sure that we've got the batteries or a power supply. It needs to run off something, so we need to make sure we've constantly got a good supply of batteries. People need to take medication to stop blood clots. And this will generally need replacing because it's got moving parts, so it will need replacing at various times. We've got two options for heart failure. We can do a transplant or we can give mechanical hearts. The transplants, again, do need to be replaced. Just like the heart valves, they do need to be replaced about every 10 to 15 years. And there is some medication that people need to take to stop the body rejecting it. To stop rejection. Okay, so we've got three different things that we can look at. We've got the valves, we've got the leaky valves, we've got pacemakers, and we've got heart failure. All problems that can go on with the heart, and we can also fix them. So we can fix leaky valves by giving new valves, either animal ones or mechanical ones. For a pacemaker, if there's pacemaker issues, we can give a mechanical pacemaker, which will help the heart beat and make sure the rhythm stays normal. And for heart failure, we can replace the heart with a transplant or with a mechanical heart. Now, hopefully that has helped with some of the lesson. You have got some questions to answer. You've also got hopefully an extended answer to do. Please complete that, make sure your name is on it and hand it in. Have a good day, and hopefully I will see you soon.